I traced out that circuit a little bit more and found that this variable control is actually working or doing what it's supposed to do, in that here's one extreme and here's the other. So it is varying a voltage, and that voltage is about right with the resistors on it that goes between the minus 15 and plus 15 volt supply, and they have it skewed more towards the positive side. So that's actually working right. So the output of that wiper goes right to a wire that goes into that box, and the voltage on that wiper is varying. What's not varying is what's coming back out. So we're sampling that high voltage with a divider, and that's that 355 that I'm trying to measure, and that is not right. Also, between the 2.7 and 910, I believe we should have plus 100 volts. So best I can read that kind of blurry schematic. And we've got 82, so it's a bit low. So everything's a bit low. Alright, so I will try taking the nuts off that high voltage box and at least see if we can see what's going on inside of it. Alright, nothing ventured, nothing gained. 2 screws removed from the bottom, detached it. 4 nuts on top, I just removed those. This would not budge, so we're using a little bit of persuasion here by way of a flat-bladed screwdriver and a small ball peen hammer, and it is coming off bit by bit. The corner is still being a bit stubborn. Voila. So they might have put some varnish inside this or something. It might have been what was holding it on. Okay. Oh, well, we got a voltage. Alright, so a couple of those nuts I didn't need to take off. So we got a little itty bitty baby fly back in here. Isn't that cute? And get some power transistors down there. It's all conformally coated. Odd looking diodes. So some of these wires coming are going to be our control voltage. Alright, so with all that conformal coating, at least it's only well, no, it might be on the bottom side too. So it's going to make testing things a little bit trickier because I got to scrape through that. So we got a cap here. Sure, or I mean, we have 2 electrolytics. No, 3. There's a third one back there. Sure, those might have gone bad. Plastic film caps, probably okay. We got a couple little tiny resistors buried in here, buried in conformal coating. Pain in the butt to deal with. It was conformal coating, varnish, polyurethane. They slathered this on here to prevent any high voltage issues, but it also means testing and replacing parts is not trivial. Before I do anything, I want to put some of these nuts back in before I lose anything. Alright, let's start by testing the smallest transistor. It is an NPN Darlington. I've got one of those universal component testers here. Let's see what it can make of it. So, bipolar junction transistor, NPN, gain of 14,500. Now remember, it's a Darlington, so it's 2 transistors connected together, which multiplies the gain, so it's going to be really large. VBE 1.2, yeah, because the 2 add together essentially, so it seems reasonable. Now I already ordered up replacement parts just on the hope I can find a bad one. Let's test the new one. Identical part number from a reputable vendor, so I don't think it's going to be counterfeit. Okay, same pinout. VBE is essentially the same. IC similar, but the gain is quite a bit more. I don't know that's going to make a difference, but this is brand new, exact same part number, so I'm going to put this in. Now, I'm not expecting to find a part that is completely shot, because after all, this does produce high voltage. It's just we can't control it. So I'm expecting something to be off, not functioning properly, but not completely dead. Now, I also got replacements for the other two transistors, or power transistors, connected to the back there for a heatsink. Seems far less likely that those are bad. In fact, the output can't be bad, because that drives the flyback, and we are getting high voltage. So if that thing was shorted, say, we would get no high voltage out. So it seems really unlikely. There's also a diode down in there, 1N4004. We can test that, which leaves the plastic film and electrolytics. I ordered up new electrolytics. I'm going to go ahead and pop those out and replace them. All the resistors I already checked, they were good. High voltage multiplier, again, we have high voltage out and it's in the range of what it should be, so I can't imagine these are bad, otherwise it wouldn't happen. What's not working is the feedback loop to control the output. So my money was on that component, and no, it's not shot, but the gain is, what, less than half of what the new part has, so that maybe that's enough to throw it off. Or we could have leaky electrolytics, so let's put the new transistor in, replace those 3 electrolytics, and then fire this back up and see if it made any difference. Alrighty, here's a 50 microfarad cap. Let's see how it tests in this device. Huh, 94. And V loss 26%. Now, typically a leaky cap, if I remember right, will test higher. So that's not a good sign. Let's check out the replacement I picked up. It's not a 50, it's 47, but that's close enough. And just about every application. And bam, almost exactly 47, and V loss 1.1%. So that's more like it. I also popped out a 10 microfarad, and let's see how this one fares in this tester. Wow, it can't even read it. Okay, well, as usual, we have bad electrolytics. It sure does appear. So, place these two guys. There's one more in there. It's 100 microfarad, I think. Let's pop that guy out and test it. Alright, let's check the last one. 100 microfarad. By the way, the replacements I got are all high quality, high temperature, long life capacitors. Alright. Unknown or damaged parts. Well, I really hope this takes care of it. So, it's taking a bit of time to get this thing open and get these parts out. And here's my replacement. And 96.6, 1.4% loss, so it sure tests a lot better than the old one. Alrighty, let's pop this in, seal everything back up, and fire this puppy back. Alright, let's try that high voltage adjustment again and see if the focus is working. So, test point, bottom of the 2.7 mag, should be 355. We adjust the control right next to it. So that's this guy right here. We got 374. We want 355. Let's see if we can adjust it now. Oh yes, we can. I see the dot on the screen is changing too. 355. I think we might have gotten it. And then this guy above it is a focus. Well, I don't have a focus on the outside of this. I don't get. It's not doing much. I'll show you what I'm looking at here. So we just have a dot on the screen here. But it seems like it's a little brighter now. And there's an intensity limit control inside of this, so I'll adjust that. Which should, yeah, okay, that's doing its thing. So you can put an upper limit on how bright you can make this to reduce the chance of burning it, I guess. But focus isn't doing anything. Now you're supposed to feed a signal in when you adjust this. And in fact, mine also just shows kind of a smudgy dot when there's no signal applied, which is not a bad thing. As if it was a super bright dot, you could damage the phosphorus, so that might be intentional. So, I think that may have fixed it, to be honest. So, we have the sweep generator back out and hook it up, and try adjusting the focus and the brightness with an actual signal applied. Alright, I got the Wavetek sweep generator going to the display. See if we can get something. Position. Cut the gain down a little. Let's turn some markers on. Could be a little brighter. Let's see. Increase that limiter. Now this main board has exactly the same type of spray caps on it, so I'd be surprised if they were a little bit bad too. Here's that focus control, 'cause it's a little blurry. Focus isn't doing anything. That's annoying. Or is it? That's just too subtle to tell. I mean, it's not horrible the way it is, but it doesn't seem to be doing really much of anything as I adjust it. Makes me, I wonder if those spray caps on there are off a bit, or should get replaced as well. Controls are a bit dirty too. It was better. It was better. But still not quite there yet. So let me do some more tinkering with this. Well, I put this project on the back burner for a while I worked on some other stuff. But I did break it out last night and do some more work, and I want to get you up to speed on what I did. I replaced all the electrolytics on the main board with some nice shiny new ones, some Vichy and some spray atom axials. And I did finally get after those two resistors that supply the CRT filament. It's a 220 and a 120 originally. The 220 I kept in there, but the 120 I decreased to 82, which got the CRT voltage, filament voltage, just under 13. I just scratched my head about that divider circuit too, because I wanted to figure out what's the CRT filament current. Now, typically a CRT, a TV, the vintage TVs I usually work on, is 6.3 volts, 600 milliamps. So I'm thinking, okay, this is 12.6 volts, so it'll be 300 milliamp filament. But if you do the math, we have 32 volts going in, and then we have 340 ohms of resistance, and then 12.6 going into that. You end up with around 19 volts being dropped across these two resistors. And do a little Ohm's law, you get about 57 milliamps, or 1/10, or 1/5 the current I was expecting. But this is newer, this is from the 80s. So maybe they had really efficient CRT guns by then. And this was meant to have be on for many, many hours in a workshop environment. So maybe it's some type of low power, long life electron gun. Alright, so after doing all that, how does it measure up? Well, I broke out mine, which has had no work done to it, and this is one I've been working on top. Let's turn up the intensity. Dot. Dot. They're actually pretty darn similar. In fact, the top one, if I go max intensity, is just about on par with the one on the bottom. Now it's static, so let's get a little deflection going. Now one problem I also noticed with this top one is there were times when that dot disappeared. I found out why. It's this auto blanking switch on the back. It's a little flaky. So there's a protection circuit built into this. You can, let's see, now it's gone. Oh, now it's back. Yeah, that switch is dirty, as are most of the switches in this. There's an auto blanking circuit that, in the absence of any signals on horizontal or vertical, will blank out the dot, which is a good thing, because you don't want to leave these running with a really bright dot in one spot for a very long period of time, or you can damage the phosphor. Now there's a switch in here. There's two of them. If you put this in the upper position, it defeats that external blanking switch, and the one on the left determines whether it will detect a signal on the horizontal or vertical. It doesn't do both. You can either say if there's no horizontal drive, blank it out, or there's no vertical drive, blank it out. Alright, well let's give it a drive signal. I've reconfigured the workbench since I started this series, and I don't have the Wavetek sweep gen up here anymore, but I do have the Hewlett Packard. So, got that going into this guy now. And notice the dot disappeared. Well, that's because we're sweeping now, so we need to turn up the intensity a bit. There it is. Over a bit. Don't have a signal in, but I think if I put the intensity down and I'll just plug in cable going to nothing, it'll just, there's enough RF noise in the air, it'll display something. Alright, cool. Let's see how the upper one compares. Intensity down, turn this one up a bit. Something about this, the switches in this are still so dirty. But there we go. I think that's usable. I think that's usable. Now what I need to do is go through the calibration procedure where you feed in a signal of known amplitude and adjust it so that the volts per division here is accurate. I also really got to clean these switches. I was taking a look at that. It's kind of sealed. It's a plastic rotary switch down in there, but there is a little slot. Maybe I can squirt a little juice in there and clean those up. Otherwise, maybe if I rotate it enough, it'll clean itself out. So I think that's good enough. If it was still dim, I would try hooking it up to a Sencor CR70, some little alligator clips, and I would try the auto restore function on it. I'm not crazy about doing that on an unknown CRT, but at least I do have the pinout on here. I'd rather not push it, especially since it's not mine. I don't want to risk burning it out. And in case you're wondering, hey, how come when we looked at the bottom one it looked like this, and when we looked at the top one, it looks like this, where we got these vertical bars. Let's pick up interference from this. If I turn the bottom one off, it goes away. So, that explains that. Alright, that's going to wrap up this project for now. The TV convention is less than 2 months away. I will be bringing this there and shoot some footage, I hope, when it arrives, showing it in the lab. Now, I also have a Wavetek 1801C sweep generator that would pair up very nicely with this that I got inexpensively, but it's dead. It does not turn on. I will try to fix it. before the convention. If not, I'll still bring it either way. I'm hoping it's a simple power supply issue, and you know, ideally we'll see them both hooked up together and working at the museum. That's it for now. Thanks for watching.